during this session, this is the third session of the week. I will be referring to a particular case study on value engineering or value analysis, you might say. And what I intend to do, actually I intend to discuss in detail all the activities which we have carried out for a value engineering or value analysis project in a manufacturing company. And main objective is, so if you go through the details of this case study, you will come to know that how a particular value engineering the study is to be conducted, what are the possible problems you may come across, what sort of the detailed information, particularly the design related data you must have, and how to implement the project, so that ultimately the company gets the real benefit out of this project, value engineering project. So the next half an hour or so, I will be discussing this particular case study, and essentially is a case study on value analysis in a manufacturing company. Now, the case study refers to an application of VA methodology. That means it is for the existing product. That's why we are saying that this is a value analysis exercise or value analysis methodology. And this case study refers to two items fabricated in a manufacturing company. Okay, and these two items we have selected for the same product, and essentially we'll be referring to the manufacturing system. And what we have explored that if you apply the value engineering say the methodology, the generic framework or the generic approach, then in the manufacturing process itself, there could be maybe lot of cost reduction and the entire say the production cost. So the value analysis has got a very wide range of application, okay, and can be applied universally whenever economy is intended. For many reasons, you will find that that value engineering at the design stage, in many cases this may not be adopted due to many other reasons, but value analysis has been in use for quite some time for many organizations. Usually the process is started with items where maximum annual savings can be quickly achieved. Like I have already mentioned, the return on investment. Now in this context, scarce materials, imported items and materials, many of our the manufacturing systems, they have the scarce materials, they have to use scarce materials, they have to use imported items and materials difficult to procure, okay, should receive immediate attention of value analysis. Like if you go for say the inventory classifications, so one inventory classifications we have, if you remember, that is SDE analysis. So in SDE analysis, what do? You try to identify the scarce mostly imported items in one group. They are referred to as S items, and in the next category you have the D item. D means difficult to procure, and E stands for easy to procure. So obviously you concentrate on say the scarce materials or the scarce items as well as the difficult to procure items for value analysis. So, how do you select the problem? Now, here let me just mention all the details. A substantial portion of the turnover of the company, sales turnover of the company under consideration is contributed by the switchgear division. The product involved in this case belongs to LT distribution range switchgear. Due to extremely keen competitive market situation, management has been left with no alternative that to find ways and means of economizing production operations for the above product. That means here we are concentrating on the production or production systems or say on the different processes and operations for the product under consideration. The total number of items, sub-assemblies that go in for the manufacture of a typical unit type distribution switchboard range from 30 to 40. Okay, so your distribution switchboard is your product which consists of 30 to 40 depending on which model you prefer or which model you use. Of these, there are items which are of true aesthetic value. Aesthetic value means essentially it is an appearance value, and some are of use value or the functional value. Out of these items, the following two items have been selected as discussed in case 1 and case 2 respectively. That means what we have selected out of all these items, we have selected one item and on that first item, and then on that you apply the value analysis methodology, and similarly we select the second item, and again for the second item we have applied the value analysis methodology. So, essentially we are referring to two cases, case 1 and case 2. So, what is case 1? Distribution switchboards are custom built to suit specific requirements. However, one common thing is that they are all mounted on pairs of similar looking pedestals for support at specified height above floor level. Is it okay? That is the support. This item, mainly the pedestal, is one of the items selected. Okay, so the pedestal is the first item, and the second item is the other item is a component of unit type distribution board. Board has one item, either 400 ampere or 800 ampere type circuit breaker attached to a cubicle which is mounted atop a pair of pedestals. This is the typical the systems they have. This cubicle, known as special double gear chamber, is a fairly standard and is selected as the other item. Okay, so the first item is the pedestal and the second item is a special double gear chamber. Now, in the present design, both items essentially consist of angle framework. It is a fabricated item with sheet steel metal covers to make up the enclosure required for the gear chamber. So, these details go through. Now, we refer to case 1. For each unit type switchboard, on one pair of pedestals is required to be fabricated. Each pedestal has two parts, namely the rectangular frame and the triangular extensions at the front. A typical pedestal with angle iron requires flame cutting and welding operations. That means you are becoming aware of the kind of operations you require for the fabrication, and you require the flame cutting and welding operations on a total of 14 joints per pair of pedestal, along with corresponding dressing operation. So, obviously there will be some dressing operation, finishing operations that you do. All holes required to be drilled on say the pair the pedestals at a time. The details of operations involved for pedestal manufacture, I am just showing it in this table. So, we will referring to that table, you will come to know what are the operations you carry out. And now, after we refer to the case 2. Now, in case 2, each unit of switchboard has one gear chamber. So, these details you must have, made of sheet metal. Gear chambers of two different standard sizes are manufactured. and the fabrication operation details are also shown in table 1. The circuit breaker, which is a cantilever end on the structure, is mounted on 2 points roughly in line with the pedestals and a few inches above it. So, I will be showing you the exact the figure and how the circuit breaker is loaded or is mounted, and 2 numbers of 14 SWG standard wire gauge side covers require 14 numbers of countersunk holes for mounting and corresponding number of tapped holes and the countersunk head screws. Okay. Now, this is the table where you will find that all the operations are mentioned, operation details are given. Okay. Just you just go through all these operations, and this is one type of gear chamber and this is the second type of gear chamber. There is some there is not substantial changes as far as the normal man minute is concerned, the operations, and these are the values of the normal man minutes against each operation, and this is these are the operations you carry out for fabricating the pedestal. So, one pair pedestal you fabricate together. So, this is the total say the normal man minutes. This is 1372, the next one is 1374, there is it's almost same, and for the pedestal, one pair pedestal, it is 879. So, this is the schematic diagram of the structures. So, this is the front view and this is your side view. So, you have the gear chamber, this is the gear chamber, these are the circuit breakers, these are the circuit breakers. This number 3 is the cable boxes, and number 4 is your pedestal, and the 5 is essentially the tie. Okay, so, this is a schematic of the presentation of the entire the fabricated body, and as far as gear chamber is concerned, this the drawing you have with covers removed. So, this is the present design, is it okay, but this is drawn not to scale. Okay. And then this is the special angle iron pedestal. When you refer to the present design, so first you refer to the present design, get the details. So, this is the front view, this is the side view, this is the angle frame, and for the pedestal support bracket you have this the front view and this is the side view, and this is the mild steel the angle, that is 50 by 50 into 6. So, all these detailed informations you have, and then when you refer to the new design, we are proposing a new design. That means the special sheet steel pedestal we are proposing. That means in the new design. So, this is the front view, this is your side view. So, what we have over here, the number 1, there is the 2 frames we have over here. This is the frames, and the number 2 is the ties you have, 2, these 2 ties you have, and 3 is basically the leg. So, which is directly you can see if you look at the side view. Okay. So, this is as per the new design. So, we have studied the existing design, and then we tried to convert it into a fabrication with sheets, say sheet steel or the sheet metal. So, that is why is the sheet steel pedestal we start calling it. Now, we formed a value engineering committee to analyze the functions and the values of the above 2 items, so case 1 and case 2, and to have an in-depth investigation, it was decided to form a committee with the following members. That means, I have already mentioned that a committee or the team is to be formed, and here is the 3-member team. So, 1 member from the design department, the 2nd member from the production department, and the 3rd member from the industrial engineering department. So, now we refer to the data collection. The 3rd member of the committee collected all the relevant data, That means essentially the industrial engineer who was involved. So, he collected all these relevant data on the present method of doing the work and the factual information required to make a detailed study of the components. Okay. So, like the information on the design, and so obviously you have to refer to the drawings. Once this was over, these data were thoroughly probed and details discussed with the other members, so that the data which you have collected that is found to be the relevant as well as they are accurate and these data are reliable. Now, when you refer to the pedestals, with the present method of working and design, the pedestal is made of angle iron having two distinct separate structures. If you refer to the drawing, you will get these details. Operation details and the corresponding direct lever given in normal man-minute, and material requirements per unit of pedestal are given in tables 1 and 2. Okay. So, total NMM required for fabrication of a unit of one pair pedestal is 879. Already we have referred to this particular table. So, the total material required per unit of one pair pedestal is 37 kg of one pair pedestal and 37 kg of MS angles including small flats and the brackets required. So, this is your materials requirement, and with reference to the special double gear chamber, we have the two types of gear chamber, one for K3 type circuit breaker and another for K4 type circuit breaker. Both MS angles and MS sheets are required for manufacturing this chamber. Okay. So, when you study its design, you will get these details. MS angle requirements we have estimated, that is 32 kg per K3 type and 34 kg per K4 type. MS sheet requirements per unit of gear chamber, that is 25 kg for K3 type and 28 kg for K4 type, and total the normal man minutes required for fabrication of one unit of gear chamber, that is 1373 for K3 type and 1374 for K4 type. So, the operation details and the corresponding direct lever given by NMM. So, you just refer to this table, that means material requirements per unit, this should be separately estimated. So, you have MS angles or the brackets or the flats. So, all these details are here, that means how much, so what is the quantity requirement, and for MS sheets what is the quantity, how much quantity you require. Okay. So, you have all this one. Now, we refer to the users value with reference to the pedestal. So, this way you calculate, we must know what is the price per kg and MS angle users value per month. Okay. So, that also you compute. The labor cost considered here refers to the direct labor charges and the variable overhead. Is it okay? So, this we have found to be relevant in this particular case. So, you have to be very careful in identifying the relevant cost elements. So, this point is to be noted. The total labor cost incurred per month is this amount. Okay. This is the one. This is just a representative value. The details of cost are given in table. So, these details are here. So, my suggestion is you please go through all these details. It is self-explanatory, and but you will come to know that to what extent the detailing is required. Is it okay? So, the table 3 actually it is basically a statement of the material cost. So, all these details are here, and then when you refer to the users value for say the gear chamber, that is the case 2. So, again you take this data, that means the price per kg of MS sheet, then the total material users value per month. Okay, it's a deterministic case. So, usually for any just make a note that for value engineering, so the case studies or value engineering exercise, usually we prefer the deterministic model, and the total labor cost incurred per month is this much, okay, and the details of the cost is given in this table. So, it's a statement of the labor cost, they referring to say it is a part of the uses value, and that is case 2. Now, how do you analyze the data? The data collected were analyzed to find out the uses the pedestal and the gear chamber are put to and the functions they serve. So, this is very, very important. So, that means what are the data you get directly from the use value or the functional value, and so that is very, very important in fact, and the members of the committee analyzed critically the functions of each component. So, as far as pedestal is concerned, the primary function of a pedestal is to hold the switchboard unit at specified height above the floor level. Putting it in a verb and noun form, that you have to do, as I have already pointed out in the previous the lecture session. So, now if you put it in a verb and noun form, to avoid ambiguity, the function would be written as hold switchboards. So, now the functions are described in terms of the verb and noun. So, the verb means hold, provide, and the noun is the hold gear chamber with circuit breakers, provide mechanical strength to assembly, provide resistance to buckling, and which part you need to select, you need to identify which part actually you need to use for getting these functions. So, for all these the functions you need to use the pedestal. As far as the double gear chamber is concerned, the primary function of a gear chamber is to hold the circuit breaker. You need to identify the primary function, then you move to the secondary function, and then if required you identify the tertiary function. So, here the primary function is to hold the circuit breaker at specified height. The functions are expressed in the following manner. Again, you will be using the verb and noun: hold, provide, give, provide. That means and the noun, and when you join verb with the noun, you get a total the sentence like hold circuit breaker unit, which part angle iron structure, that you have to identify. Then provide bus bars, CTs and other electrical accessories, that is basically done by the gear chamber. Provide support to bus bar connection and insulation, side covers of the chambers. Give access to inner electrical fittings and equipment, covers of the chambers, and the provide mechanical strength, obviously it is given by the angle iron structure. So, this way you present the details of the functions. The value of any service, material or product is established by the minimum cost of other available alternative materials, products and services that perform the same function. So, these aspects are also known to you. So, use value is based on the properties and quality of a product or material in relationship to the purpose of the item. This point already we have elaborated. So, the different ways, the same concept we are trying to explain. So, the use value is your objective and the cost value is based on cost of product expressed in monetary terms. So, while analyzing the data collected on the following criteria, emphasis was given on the following. That means these questions are asked. Like the first question, one important question you must ask along with other questions, that is it over designed or is it under designed? Can it be simplified? Many cases you may find that it is over designed. So, the first purpose should be, can it be can an alternative design be offered? So, several other the queries you raise related to the special requirements information, like are special procedure required. Okay. So, you just go through all these queries, you get the details. It's a detailed say the list of the questions. This is the special requirement, and these are the two questions you must ask. Related to materials, you must ask this these 5 questions. So, please go through them. Processing information. Is this difficult to manufacture? Is there a less costly method? Okay. And then you go for the value summary. Is this function unimportant? Okay. You explore all sorts of possibilities. Does this cost more than it is worth? Okay. Are customers really realizing the use of the item and the process of manufacture? So, all these details. Then during the speculative phase, again the following questions were asked. Just some of the questions I just consider very important, like can any function be eliminated? Can any part be eliminated? Can any part be combined? That means when you refer to design improvement, the 100 ways, there are different ways you can go for design improvement. So, these are the typical questions we ask, okay. And particularly when the product actually you are referring to is nothing but an assembly. So, can a cheaper specification of the same material be used, and can another material be used? So, all these questions are there. So, the idea generated were as follows: change of method, that is one idea, that means you need to change the method, and the change of materials. Okay. So, the cheaper specification of MS angles used in the present manufacturing method can be changed to go for a less costly and equally effective materials. Is it okay? Similarly, for the case 2, we opted for change of method and the change of materials. So, these are the two decisions we took, and then we have recorded the ideas, and that means the committee members were involved in recording the ideas, and further and these the ideas are to be recorded properly for further investigation. All ideas pertaining to the design and material were recorded in both the cases. Then so this is the first idea, that means you have to change the method of manufacture, and the second idea was that of changing the materials. Similarly, for the gear chamber, that alternative methods were suggested, were evaluated and then suggested, and the change of materials to bring down the weight of the product is feasible. So, this we have also concluded that this is a feasible alternative. So, we go for further refining the ideas, that is natural in fact, that means through the several sittings, through several meetings, and some of the important features are worth mentioning over here, like with respect to the case 1, rectangular frame designed with the existing steel eliminates need for separate triangular frames and corresponding hardware materials. So, these are the important points. Okay. So, please go through them in a systematic way. We have written all these details, okay. And then again for the case 2, you refer to the figure, and you have all these say the suggestions, and so there are 5 suggestions. So, here what we do, that means for the old sections we carried out this analysis, okay, ZX, ZY. So, we calculated this. Similarly, the new sections we calculated the value of ZY as well as the ZX. Okay. So, this analysis we do, and for the old section as well as the new section. So, please the check or just to verify what are the changes in the sections, okay, in the sections. And this is the new design for the gear chambers, and there are few recommendations, and this is the savings we calculate for both case 1 as well as for the case 2. So, the details are given, the operation details per unit of pedestal, and this is the material and labor cost per unit of pedestal, 1 pair pedestal. All these for the new design we have this breakup, and similarly the cost comparison of the present and new design. So all these details are here. So you please refer to all these tables, and then we come to the implementation part. So we have the verified the new designs from the different perspectives, and ultimately we went for their implementation. So a meeting was convened of all the value engineering committee members and the production personnel, and the suggestions are condensed form. In condensed form were decided to be presented to the persons concerned, and the implementation phases were outlined as follows. So this is the implementation phase. So it's the 3-step implementation phase, and then ultimately we also convened a meeting with the union representatives to remove misconception, if any, regarding the investment and the possible reduction in the workload. That means you have to be take an open approach. That means the person concerned should be very clearly informed that what are the new changes made, and why these new changes, and to what extent you get the benefits at all levels. So this is a case we are referring to, and as you might have noticed that this case study that deals with almost all aspects that to be considered while you implement a value engineering or value analysis, say the project. So please follow, or please go through all the details, and so that you will come to know that how important such an exercise is. Thank you.